Okay, so in this video, I'm gonna talk about linear differential equation. The linear differential equation will be the equation that we have a specific form and we're gonna have a specific solution. So it's gonna be like one formula for the solution for the linear equation. Okay, so first I'd like you to be able to identify the form. So you have the linear equation. It's going to turn out to be the equation of the form dy dx equal to px times y and equal to qx on the other side. So you see it's going to be same format in each question that you're going to have linear equation. Okay, so it's going to be dy dx plus px times y equal to qx. Okay, so let's take a look at this equation. So you have dy dx equal minus y over x equal to log x. So for this one, it's going to be dy dx minus, so it's going to be plus negative 1 over x, okay, y equal to log x. And you'll be able to identify the green guy, which is px, and the pink guy, which is qx. Okay, so this one will be qx, and this one will be px. Okay, so you must have to be able to identify px and qx first. It's going to be important later. Okay, let's do one more. So you have y prime, okay? So xy prime. So you try to put into this form and you need to be able to identify the green function and the pink function. So for this one, you see that it's not dy dx yet. So it's going to be y prime plus 2 minus x over x times y equal to e to the x over x. Okay, so this one will be this differential equation, and you're gonna have to be able to identify qx and px. Okay, so this would give you px and this would give you qx. Okay, so that will be linear equation. So I'm gonna say it's linear. Okay, so after we know that our equation turned out to be linear equation, we're gonna be able to solve by using the formula. Okay, let me derive the formula for you. So when you know that your equation turned out to be a linear equation, you're gonna set up mu equal to e to the integrate px dx. So you're gonna set up mu to be e to the integrate px dx that I will highlight the orange one. Okay, so this one will be mu. And why this mu is important? This mu is important because when you differentiate mu with respect to x, so you're gonna be differentiate e to the u. So it's gonna be e to the u and you differentiate u. So it's gonna turn out to be e to the integrate. So this guy turned out to be just, mu, right? So this one is the same color. So this guy turned out to be just your mu before. Okay, so this guy you see is going to be just mu. And you have derivative of the blue guy. So it's going to be dip and integral will cancel each other. So you would get just px. Okay, so this one will be d mu dx equal to mu px, and you have d mu equal to mu px dx. Okay, so the above linear equation, okay, so the above linear equation turned out to be, so you see that mu px dx, okay, so this one, if you multiply the whole thing by dx, Okay, so this one, if you multiply the whole thing by dx, this is what you get. So you would get dy equal, not equal, plus pxy equal to q dx. So you multiplying both sides by mu, okay? So you get mu dy, mu px y dx, and mu qx. And you see that mu px dx, mu px dx, let me highlight the blue color. So you see mu px dx, mu px dx. So for this one, it's turned out to be what? It's turned out to be d mu. It's turned out to be d mu. So this one is the blue color, okay? And you have y dy copied out, y dy copied out, y dy, I will just copy it down, y dy, okay? And mu qx dx, I just copy it down. And you see here that this one turned out to be mu dy plus y d mu. So this one is going to be just the product rule. So you have d mu y equal to mu qx dx, and you can integrate both sides. Okay, so you can integrate both sides, and you get mu y equal to integrate mu qx dx. Okay, so from this long verification, you're gonna end up with y. Okay, so you're gonna end up with y, which is the important one. So you get y equal to, okay, so you get y equal to 1 over mu qx dx. Okay, so you get 1 over mu integrate mu qx dx. So this one will be the general solution. Okay, so this one will be the general solution, and you're gonna use this formula. Okay, so formula for solution. Formula for solution of linear equation. Okay, so formula for solution, you're gonna get this one, and you have to like memorize or recognize mu also. So you have your mu, okay, given by mu equal to e to the integrate px dx. Okay, so this one will be the formula for the solution here. Let me put article a little bit, should be the solution. Okay, so let's use the formula in order to find the general solution. So let's first find mu. Okay, so let's first find mu. Mu in this case will be e to the integrate px dx. So it's going to be negative 1 over x dx. So this one is the green color. So it's going to be e to the negative log x, okay? And it's going to be e to the log 1 over x, okay? So negative log x is log 1 over x. It's going to turn out to be 1 over x in this case, okay? So you have mu equal to 1 over x. One of you, normally some of you will ask me a little bit that, hey, can we just put absolute? You can, but in this case, it's not necessary because you need mu only in order to use in this formula. Mu here can be, so you don't need to put absolute value into this guy and plus c yet, because this one is in the middle of the calculation. Okay, so you just pick one side and I pick positive side. So you can use negative side also. So if you feel that, hey, can I just have log absolute x? You don't have to. You can assume that it's going to be positive, so it's going to be just log x. It's not final answer yet because this mu will be used to find y, and when you find y, that will be the place that is going to be serious. Okay, so after you have mu equal to 1 over x, you're going to obtain y equal to 1 over mu integrate mu qx dx. And this one will be 1 over x integrate 1 over x log x dx. Okay, so this one will be just the thing that you have for mu. Let me highlight this color. So it's going to be mu, it's going to be mu, and you use these two guys like this. And you see that you have to find this one by substitution. So you're gonna let u to be log x, and you have du equal to 1 over x dx. So this guy become integrate u du, and it's going to be u squared over 2 plus c. Okay, so it's going to become integrate u squared over 2 plus c. So this will be x, okay, and inside parentheses turn out to be what? Log x squared over 2 plus c. And this one will be just that, okay? Okay, and this is your final answer. One thing that I want you to understand here will be this one take place inside parentheses. Okay, so the whole thing here is inside parentheses. So you must put parentheses. This one not equal to x log x square over 2 plus c. Okay, so this one, so the black one and the red one are not the same because you see that it must be x times c. So it's going to be cx if you need to have it correctly. Okay, so be careful on this one, and this is the common mistake that you make during solving the linear equation. At the end, this one, you must put parentheses, and the c that you plus at the end of the solution turn out to be inside parentheses. Okay, so be careful on that. That is the common mistake that you most make during the calculation. Okay, let's do one more. You know px and qx respectively here. So you're gonna find mu. Okay, so you're gonna find mu. So it's gonna be e to the integrate 2 minus x over x dx. So it's gonna be e, and you integrate 2 over x minus 1 dx. Okay, so for this one, it's going to be what? It's going to be integrate 2 over x, so it's going to be e integrate 2 over x, so it's going to be 2 log absolute x. Okay, integrate 1, you get negative x. Okay, like I said, you don't need absolute yet, so you just assume that you have x positive. Okay, and then this guy will be e to the log x squared times e to the negative x. Okay, and e to the log x squared turn out to be x squared times e to the negative x. Okay, so this one will be your mu. So after you have this mu, it's gonna turn out to be y. Y in this case is gonna be 1 over mu x squared e to the negative x, and you're gonna integrate, integrate what? Integrate mu, which is x squared e to the negative x, and you're gonna multiply by qx, so it's gonna be e to the x over x dx. Okay, so this is what you should have. And this one turn out to be e to the x over x squared, and these two guys will cancel each other, and x squared and x, so you end up with something very nice. So it's going to be x dx only. Okay, so this one first seem hard, but it's not that hard to integrate. So this one you gonna solve for y, so it's gonna be e to the x over x squared, and integrate x dx, so you get x squared over 2 plus c. Okay, so here don't forget to put parentheses. Okay, so this one is inside the red parentheses, so you're gonna have this one in terms of parentheses here. Okay, so that is gonna be the final answer. And don't forget that you have C inside parentheses. For this one seems like separable. You see that it almost looks like separable. However, you not be able to separate y on one side and x on the other side as usual, because you see an extra y here that kind of in the way that is not allow you to move much. Okay, so the thing that we gonna try to do is gonna be, so we're gonna try to put in the form of dy dx. Okay, and I'm gonna divide the whole thing by 1 plus x squared, so it's gonna be e to the 2x over 1 plus x squared minus 2xy over 2xy over 1 plus x squared. Okay, so I move the x to join with dy. Let's recap what I did. So I move the x to join with dy, and I divide the whole thing by 1 plus x squared. So you see that this guy turned out to be dy dx plus 2x over 1 plus x squared y equal to e to the 2x over 1 plus x squared. And you see that this will be your p and your q respectively. Okay, so this one will be your qx and this one will be your px. Okay, and you see that you're gonna find mu. Okay, so mu will be e to the integrate 2x over 1 plus x squared dx. Okay, and you're gonna find y for me. Okay, so I'm gonna leave this question for you to complete, and I will give you the solution during the recitation. Okay, so this one will be the linear. Okay, so this one is linear. And we have the formula for solving this guy. Okay. Last one. Okay. Last one is still you like to find the particular solution. So in this case, you're gonna have dy dx, okay, minus y over x log x equal to 1 over x. So in this case, try to identify p. Okay, so this one will be negative 1 over x log x, y equal to 1 over x. And this one will be the green one. This one will be the pink one. And this one will be your px. This one will be your qx. Okay. And you see that you're gonna have to find mu. Okay, mu will be e to the integrate negative 1 over x log x dx. So it's gonna be e, you have negative. So this one you integrate by letting u to be log x again. Okay, so you let u to be ln x, and you have du equal to 1 over x dx. Okay, so you get negative and you integrate 1 over u du. So it's going to be e to the negative of what? Negative of log u. Okay, so it's going to be negative of log u. So it's going to be e to the negative of log x. Okay, so it's going to be negative of log x. Okay, so that my e, and you have what? You have e to the negative of log x. Okay, u equal to log x. So it's going to be e and log. So it's going to be 1 over log x. Okay, so it's turned out to be 1 over log x. So you're gonna have y for me. You're gonna have y, so it's gonna be 1 over log x integrate 1 over log x times 1 over x dx. So this one is the orange color. This one is mu, and you have mu, okay? And you see that this one turned out to be log x integrate. Again, 1 over x log x, you would let u to be log x, same as the above. And you have du equal to 1 over x dx. So it's going to be 1 over u du. So you would have log x, okay, and log u, okay, so log absolute log x, log absolute u plus c inside parentheses, okay, and it's gonna turn out to be log x, okay, so it's turned out to be log x, and you have log absolute log x plus c, and you're gonna put y equal to 2x equal to e. So this one is your y, okay? And I'm gonna say that sin y e equal to 2, okay? So because y e equal to 2, so you would get 2 equal to log e multiply with log of log e, okay, plus c, and log e equal to 1, log 1 turned out to be equal to 0. So you're gonna get c equal to 2 over 1, okay, log e equal to 1, so you would have c equal to 2 in this case. And your particular solution would be log x, okay, multiply with log absolute log x plus 2, okay, so that will be my final answer. Okay, it's a little bit long, however the integration turned out to be repeat. Okay, so the integration turned out to be repeat, that you have to integrate 1 over x log x twice, okay, in order to obtain the final answer. Okay, so that's all for the linear equation. We're gonna do the application next.